Welcome. So we're now going to talk about communication matrices. So a communication matrix is a square binary matrix where the ones represents links in a system. They're often used to track communication between participants in large projects. Okay, so here are the key components of a communication matrix. Now, as we're reading through this, not much of it is going to make sense at first. Only once we go through some examples will you be able to kind of go back and look at this, and then it will make sense. So this part right here is something that you really need to go back to once we've gone through examples and make sure that you can make sense out of all of it then. We're still going to read it through now, but just be aware of that. So a communication matrix is used to show direct one-step communication links between objects or people. M is a binary matrix. Ones represents a connection where 0 represents no connection. M squared represents the two-step communication links. T is equal to M plus M squared represents the total of one and two-step communication links. Further links, 3-step or more, can be found and added to the total. So for example, M raised to the power of 3 give all 3-step communication links. So that would be M plus M squared plus M cubed. And then M to the 4, all 4-step links, and so on. The leading diagonal of a communication matrix is redundant. And again, once we go through an example, we'll really be touching upon that. And the value of each element in matrix T represents the total number of communication paths between the row and column variables. Now, as I said, none of that should have made any sense to you because we haven't seen an example and you really don't have any context for any of this. But once we go through an example, you'll be able to come back here and read through all of this, and hopefully everything here will make sense. Okay, let's now go through an example together.